Welcome back, Math 098. We're going to finish up. So hopefully you tried this problem on your own, and what you need to do is just compare it to 0, just like what we did all other problems. And again, this is basically saying, hey, we want values that are below the x-axis. If we look at the graph, we want negative answers. Well, as we look at this problem, it's not factorable. There's no factors of 7 that add to be 3. And if you did the quadratic formula, negative 3, negative b plus or minus the square root of b squared minus 4ac all over 2a, 2 times 1 is still 2. And again, just like what we did in this problem over here, looking at the radical, we'd be square rooting a negative. 9 minus 28 would be negative 19. Anyway, it's a negative, so that means it never crosses the x-axis. So what's the difference with this problem and the previous one? Is it's still a upwards parabola. So whatever the graph looks like, I think it looks pretty much the same as this one, and you can use a graphing calculator or Desmos to figure that out. But this time the direction is saying we want negative numbers, and it's never below the x-axis, so therefore this answer is no solution. That's what we're looking for on this problem. So pretty much the same work, they just changed it a little bit around. They threw in a below the x-axis, whereas this one was always above the x-axis. This one is never below the x-axis. And so that's why this one's no solution and this one's all reals. Huge difference there. So as I'm working through a few other problems, we can do problems like this in comparison to 0 in the same way. But notice that it's, instead of a multiplication problem, it's a division problem. So this exercise is pretty straightforward. It's very similar to the other one, where you want the numerator and the denominator equal to 0. So when does that happen? The numerator equals 0 at x equals 5, and the denominator equals 0 at x equals negative 4. But this time we have a different approach to this, because the numerator can equal 0 and we can divide, but the denominator cannot equal 0, because then we'd be dividing by 0. So if you were to make the same sign chart that I showed you in the first video, and you put in negative 4, put in 5, the difference here is now you want an open circle at negative 4 because it's in the denominator, and a closed circle at 5. Because it's okay for the numerator to equal 0 and equal 0. Notice on the last exercise over here, both of them are going to be open circles because there's no equal to here. But I have a lot more to explain on that one, so that one's not very easy. But I'm going to do the problem just like I did the previous video, where you choose numbers like negative 5 to the left of negative 4, 0 is in between those two, and 6 is to the right of 5. So let's start with negative 5. If I plug in a negative here, negative 5 minus 5 is negative 10. Negative 5 plus 4 is a negative. Well, a negative divided by a negative is a positive. The fact that we want less than 0 is we only want negative values, so this does not work. If we plug in 0, though, well, 0 minus 5 is still negative. 0 plus 4 now is positive. Is it true that a negative divided by a positive is negative? Yes. So it works here. And then plug in 6. 6 minus 5 is positive 1. 6 plus 4 is positive 10. A positive divided by positive is not negative, so we don't want that answer. So our correct answer is from negative 4 with a parenthesis, because we do not want it to equal negative 4, but a bracket at 5. And just like before, you could show that this is the correct answer, because if we want negatives, we want them to be below the x-axis, and the fact that it's equal to, it could be on or on the x-axis. So I'm going to show you with my graphing calculator what you can look for. So change my graph. I'm just going to make it into a fraction, I can do it by hitting alpha x. Some other people might need to hit alpha y equals and then enter right there. And then you can type it in, x minus 5 over x plus 4. If I go to my graph, you can see it's below the x-axis from -4, but there's a vertical asymptote at x equals -4. That's why you cannot include it all the way until we get to 5. And the moment we hit 5, we are above the x-axis. So we want to include 5 because it's on the x-axis there, but nothing past x equals positive 5. And let's brace ourselves for the last problem. You might want to hit pause in the video or really soak all of this in. You might want to try a few problems. That's fine, because this last one is very difficult. And the reason why I say it's very difficult is just like in the first 5 examples and the 6th one, we had to get it equal to 0. So it's starting the same way where you have to subtract 5 over to compare that number to 0. Well, now what you need to do is get the same denominator, and if it helps, put 5 over 1. So your next step is to multiply this denominator by x plus 3, and that's only acceptable if you multiply the numerator by x plus 3 as well. So now the like denominator on both of those is x plus 3, and we can go ahead and subtract those numbers. Make sure you distribute this -5, though. It is a -5 to distribute, so it's really -5x. And then it's -15, and we can combine that -15 with this positive 7. I hope you understand where I'm coming from there. So that's -8. So as we compare our numbers, I'll switch back to green, the two numbers we care about are going to be -3 for the denominator. And if you set the numerator equal to 0, -5x minus 8 equal to 0, add 8 over and divide by -5, our other number we're looking at would be -8/5, which is about -1.6. Notice that because it's a less than, there's no equal to, they're both going to be open circles. Okay, so I covered the open and closed on the previous problem, but because it's less than, it doesn't matter. They're both open circles. We're going to have parentheses. And one more thing is we are looking for negative answers because negative is less than 0. So what I'm going to try is numbers like -4, -2, and 0. And to me, 0 would be the easiest because in the numerator, we'll get -0 is still 0, -8 we get a negative, and 0 plus 3 is a positive. And it is true that a negative divided by a positive is negative. So this side does work. But when I try -2, well, -5 times -2 is positive 10, minus 8 gives me a positive, and in the denominator, -2 plus 3 is a positive. A positive divided by a positive is positive. This one does not work. And if you try this last one, it will work. Let's verify. -5 times -4 is positive 20, minus 8 is positive 12. -4 plus 3 is a negative, and a positive divided by a negative is negative. So this section works as well. So what's our final answer in interval notation is from -infinity to -3 union -8/5 to infinity. So I recognize that that's very difficult. I would encourage you to use a graphing calculator to check this answer, and you should be ready for the homework now. And if you have any questions, please write them down, email me, bring them to class, whatever you need to do to be successful.